Hey everyone, and welcome back to Fill Engineering, finally. If you've seen my previous videos, you know that I just got a milling machine and a lathe. But of course, just putting machines in the middle of a room does not really make it a machine shop yet. So I have about 5 square meters of space left and 2.5 tons of machinery plus tooling. So let's see if a shed-sized room is enough to build a machine shop. The very first thing to do is to get all this junk out. It's always amazing how a dedicated space turns into a scrapyard in no time at all. Before I bought the machines, I marked the floor with tape because I wanted the biggest machines possible. But before we can find out if I miscalculated this, there's a slight problem with the mill. The ram sticks out quite a bit and I really need every bit of space. So there are two options right here. I could either shorten the ram by cutting a piece off, which would be a death sin, or I could just punch a giant hole into my wall, which is exactly what I did. And yes, I actually did speak to a construction engineer before doing this, and since the wall is almost 1 meter thick, it is not a problem. I fabricated this steel insert to cover up my carnage and concreted it into the wall to fill any gaps. Now everything is ready for the move. Now I didn't film much of the process because I really wanted to focus on what I'm doing, and if you want to know how you can do this kind of work yourself safely, watch dedicated videos about it done by professionals that tell you exactly what you need and how you should do it. In my case, I parked the mill right beside the workbench to create enough space for the lathe to pass through, which I drove back outside to turn it around. Then it was just a matter of getting the position right and setting it onto some wooden blocks to get the pallet out. The mill was, besides its weight, pretty straightforward. I just needed to pay attention that I'm perfectly in line with the wall insert. For lowering them onto the floor, I ordered a toe jack. You could do it with a big pry bar, but this is much safer. The lathe still needs some anti-vibration feed, and I got the original leveling screws, which are rounded, so they will register inside this bore. And after installing 5 more of those, this is how it looks. This allows me to level the machine and take any twist out of the bed. Again, there are dedicated videos about leveling if you want to do this work on your own. Took me about 2 hours to find a precision level, and I will check it in a few weeks just in case the floor has settled under the weight. Next up is remounting the vertical head on the mill. I had to get it off to pull the ram forward. Looks like I have about 20 mm of space left behind the ram when the head is back on. That is actually much closer than I thought it would be, but that's a good thing because it means I didn't remove more of the wall than necessary. The last thing to do is getting the knee handle and hand wheels back on, and the mill is ready to use. I totally thought I would need to sacrifice a bit of travel, but to my surprise, it just fits as long as I don't crank the knee all the way down. In my last video I told you I needed to make a proper tool post stud, because this one is way too small for the new tool post. But in order to turn threads, I need something this machine is missing right now, which is the threading dial. Basically impossible to find used, so I had to reverse engineer it on my own. Let's chuck up a piece of steel for making the central shaft. It gets phased off, and then I can start working on the diameter. Remember that I can only take light cuts, otherwise the cutting force will just shift the entire tool post. And without the proper feed rate, it is very difficult to break a chip. I'm drilling a center in the end to bring a bit of tailstock support in, and then I slowly work my way up to the final dimension. A backwards facing cut at the end, and before I move on, I need to remove this dangerous bird's nest under the chuck. The end gets a step and some thread relief. I'm using a drill chuck in the tailstock to lightly press against the die to make sure it cuts a straight thread. A quick test with a nut, and this side is finished. Here's what it looks like with the gears and spacer in place. The other side is straightforward, just a step down, but I'm leaving this middle section as an integral spacer. Shooting for 60mm, and it's right on. Then partially power tapping the end and finishing it by hand. The lathe work for this part is done, and the last feature to make is a small keyway. I only have a cheap end mill the right size, which, besides being brand new, cuts like a butter knife. But after cleaning it up, it looks alright. The key fits nicely, and this is how the gear will sit on it. Back to the lathe to make some thumb screws or nuts out of aluminum. Stock is turned down, so prepare yourself for the world's shittiest knurling tool. Turned out okay, but it's definitely on the finer side. Now some big chamfers, mainly for looks. I'm drilling quite deep because I need 2 of those parts. Then a lead-in chamfer before power tapping it all the way. For cleaning up the parted side, I'm just using the shaft I made before as a mantle. I made a few simple parts off camera, and now we can assemble everything. The main body gets this top bushing glued in place, which is a tight fit. The lower bushing has a looser outside fit, so I can use the main shaft to force it into alignment while the glue is drying. Every gear has its keyway right underneath a tooth to make sure they are synchronized with each other, otherwise the dial would not work anymore after changing the gear. The dial needs to get tightened down on the machine to synchronize it with the lead screw. I'm checking if the keyway tooth is in the middle, and then I can slide it on to mesh it with the lead screw while the half nuts of the carriage are engaged. Let's see if this thing works. Actually, not too shabby. I can swing it out of the way when I don't need it and engage it when I want to turn some threads. And to be honest, it actually looks pretty sharp. But just this little amount of turning made quite a mess. And to solve this, I got some wood. I want to build some anti-fatigue mats or shop floor, which leaves space for chips to fall under it, and it has a bit of springiness to it, which is much easier on your legs than hard concrete after a few hours of standing in front of the machines. I noticed my room has a slight taper to it, so I opted for spreading the boards out in one direction so it's not that obvious. Then it's just a matter of gluing, drilling and screwing for each joint. I make 3 separate sections because I still need to get them out if the time has come to collect all the stuff underneath it. For the front I cut this piece to act as an end stop, as I don't want these mats to slide around. To make them not stand out as much, I'm painting them in the exact same color as my epoxy floor, which will also make them a bit more durable. The mill power cable is in the way when sliding the segment in, so I printed a simple hook to hang it off the floor. And with the last segment in place, I can return to the lathe to finally machine the tool post stud. I have this piece of 42 Chrome 4, which is some really tough stuff, perfect for parts that see high amounts of stress. The bad thing about this stuff is that it wants to curl up really fast when feeding slow. So after almost every pass I stop the spindle to get the bird's nest out of the way. I'm shooting for just under 32mm, as this is the bore size of the multifix tool post. Then a step down at the end for accepting the top ring, which got a bit spicy at the shoulder. And another step down for an M20 by 2.5 thread. I wanted to be fancy and color it, but my Sharpie died. First a scratch pass to check if the machine is set up right. And then I immediately double threaded by engaging at the wrong number. But it's not a problem if I just stick with the new number. I'm slowly advancing the compound until the fit is just right with the flange knot I bought. I finished the other side of camera since it is almost the same, just a smaller thread. And if it looks slightly different, this is because I modified the shoulder length to give it a bit more clearance with the top of the tool post. but the stud itself will not prevent the tool post from rotating away under the cutting force. This is why it has two holes for securing it in place with a pin. I set the compound to 29.5 degrees, as this is a setting it will be in for most of the time. And then it gets indicated into the cross light. I use the parting tool for it, as this tool doesn't allow the slightest amount of misalignment. I can then transfer one hole location to the compound, which gets drilled and reamed. I somehow lost the footage of that, or just forgot to hit record. Oh, and by the way, the stud doesn't have any wrench flats because I'm waiting for an indexing head to arrive. Indicating the compound back in and tightening everything down to finish this install. Now for the tool holders themselves, I came up with this design to store them on the wall in the background. I first need to work out the spacing, as I want to have them on a 45-degree angle to give more space for the tool inside the holder itself. I designed this to have two screws going through the entire part, so I don't have to rely on layer adhesion to prevent the holders from crashing down. The second row has 3 of them sideways for boring bars and the other 3 for regular turning tools. Now I need something for the tailstock tooling as well, so it is again time for peak woodworking. I designed inserts that have 3 little ridges to prevent the moss taper from sticking too hard. And I made this 6-pack type thingy for smaller tools like dead centers. And after installing way more screws than necessary, this is the finished board. I just glued it in place, and then I can organize my moss taper tooling. It has enough headroom to fit big drills, just in case I need them on hand. Next up, I recorded this time-lapse of me fabricating a lathe chuck rack, but most of the time all you can really see is me getting bored. Emotional damage. I painted this masterpiece and this is the spot it will live in. To prevent it from scratching anything, I put some felt stripes on it, but I need to buy a few more of those. This quick change collet chuck came with the lathe, and right besides the chuck rack I fitted the plate for the collets into my wall. To organize generic tools that I need while machining, I, surprise, printed some more stuff. First I'm mounting the hold down hardware, then a tray for pens and scribes, a magnet for random stuff, a steel plated shelf for Mac bases, my deburring tool, multifix wrench, thread gauges, calipers, drawbar wrenches, a rule, a tray for safety glasses, some bigger calipers, a chuck wrench, my soft blow, another chuck wrench, and at last a brush. While I was working on that, another tool arrived. An original 40 taper tool boy for setting up mill tooling. This is much nicer than hammering on tools in the spindle. Some flimsy screws for now, just to test it, but I changed them out for bigger ones later. I have this small vise flying around, so why not install it here for holding parts while deburring or whatever. Of course, this needs soft jaws, but I'm running low on aluminum right now, so this has to wait. And finally, the very last thing to do is putting something inside this documentation holder. If I try to take it off the lathe, it will just rip the entire paint off, so I'm just putting a lubrication shard inside because why not? We are finished. So, what do you think? I really love the way it turned out. You know, not long ago, this has only been a dream and now here it is. And yes, this is right at the limit in terms of space, but as long as I can move around, I'm totally fine with it. But of course, a machine shop is never really finished. There's always something to add, something to improve upon. But for now, this shop is ready for its first project. So, stay tuned. Thanks for watching.